Let's consider some of the values we can attach to a moving object. From GCSE, you're probably used to considering time, speed, distance, acceleration. We're going to slightly adapt some of those and become more clear in our definitions of speed, time, acceleration, distance. So let's start off thinking about these in terms of on a graph. So if we have a speed time graph, I'm just going to represent that with SP for speed, you'll see why later. You would often have some sort of journey to college where you accelerate, move at a constant speed, and then arrive at college and stop, remain at college for some period of time, and then you would leave and return home. Again, some speed for some time, and then stop. This is what we refer to as a scalar property. Scalar means it only has a size, a magnitude. So the quicker you're moving, the higher speed's magnitude. It doesn't matter which direction you're moving in. Importantly, in this case, moving to college would be at the same speed as going back home. However, at A level, we want a little bit more information, so we're going to consider something called velocity. Velocity is what we call a vector measure of speed. So this one also has a direction associated with it. In this case, we would represent it as negative when we wish to go home. So arrive to college, positive speed because we're heading away. We're going to be adding to our displacement, which is our vector form of distance. And then when we return home, we would have a negative velocity because we would be reducing our displacement, our vector velocity, our vector version of distance. So like we said, vectors can be positive or negative as they show a direction. There I kept mentioning displacement. Displacement is how far you've travelled in a given direction from where you started. So for example, going to college, we would be increasing our displacement and indeed our distance until we arrive at college. Distance would usually then continue to increase on your way home. This would be like the odometer in a car, which measures total distance travelled. However, displacement would measure how far we've travelled from our starting location. So when we arrive back home later in the evening, we would have zero displacement. An outside observer who didn't see you travel to college and then return would consider you to have not moved, so your displacement would be zero. Similarly, if you then went in the opposite direction, let's say that you lived in St Ives and you then went out on a boat in the evening, you would have a negative direction, a negative displacement, sorry. Okay, so just like velocity can be positive for going in one direction and then negative for moving in the other direction, displacement can also be positive or negative. Finally, we come to acceleration, these bits where velocity is changing. Acceleration can also be negative or positive, it's also a vector measure. So we would describe acceleration in one direction, i.e. an increase in speed this way, as a positive acceleration. And then if you started to accelerate this way, or indeed you slowed down, so you may still be travelling in this direction, but now more slowly, your acceleration would be in the opposite direction and therefore negative. So with these new measures, you're used to scalar measures from GCSE, which only had a size. We now have a size and a direction. They're vector quantities. We refer to those as velocity, displacement, and we still refer to acceleration as acceleration. So that one doesn't have a different name for the scalar and vector quantities, but we just have to be very, very careful when we interpret a question whether it is positive or negative.